Yogah Karmasu Kaushalam.
Today, we are going to discuss the canonical transformations in classical mechanics, which is a very important topic in TYBSc as well as in post-graduation studies. Classical mechanics is a very important one of the core theory papers, and canonical transformation is forming a very important topic in classical mechanics. So we are going to discuss the canonical transformation in classical mechanics, and we'll try to discuss what are the difficulties students face in discussing the canonical transformation. So first, we try to understand what is canonical transformation. In the Hamiltonian mechanics, a canonical transformation is change in canonical coordinates, as we have mentioned here, small q, p, and t to new coordinate or canonical variables, that is capital Q, capital P, and T, and the preserving the form of Hamiltonian equation. So this transformation is carried out by preserving the Hamiltonian equations, and sometimes this is known as form of invariance. So this is a very important the transformation that is from small q, small p, and t to new variables, that is capital Q, capital P, and T. And it is need not to preserve the form of Hamiltonian. So it forms the Hamiltonian equation, it preserves the form of Hamiltonian equations, but it need not preserve the form of Hamiltonian, and that is a particularly important part. A canonical transformation is a phase-space coordinate transformation, and associated transformations of Hamiltonian such that the dynamics given by Hamiltonian's equations in two representations describe the same evolution of a system. So this is a transformation in a phase space, and there are two transformations. They are coming up in the same time or evolution of same time. Now we come to another slide. We take the two examples to understand the canonical transformation. Usually, for the students' point of view, the textbooks, they have a typical language, and it is very difficult for student to digest. So I have taken two examples to understand the canonical transformation. Now, one example is of a classroom, and there are two situations. One situation is where the classroom is full, so all students are present. And another situation, the classroom is completely vacant, no students are there. And these two extreme conditions are not usually observed. So these are the two extreme conditions. Normally, in a classroom, some students are present, some students are absent. But the absent students are present somewhere. They are present, not in the classroom, but they are present outside the classroom. So let us assume the situation that the students present in the classroom are represented by the variables like small q, small p, and t. And the students present elsewhere, not in the classroom, they're represented by new dynamical variables like capital Qi, capital Pi, and T. And a function f is relating the students who are outside the classroom and who are within the classroom, because that relation is for the particular group of students. So small pi, small qi, and t, that represents the whole system. New qi, pi, and t means capital Qi, pi, and t represents the new system. And function f relates that the students who are outside the classroom and within the classroom. So that function relates the nature of the students. Now, another example is a bridge connecting the two sides of a river. So side A is represented by Pi and Qi and time t, and side B is represented by Qi, Pi, and t. And these two sides are connected by a bridge. So bridge works as a function f that connects the one side of a river with the another side of a river. So in canonical transformation, it is called the generating function. So generating function is working as a bridge connecting the one set of canonical variables with the another set of canonical variables. Now we take the another example of bride and groom. So wedding is a relationship of function f. So bride's family is represented by Pi, Qi, and T. These are the small variables. And groom's family is represented by Qi, Pi, and T. These are the capital letters. So that is the new variable. And the couple correlates the two families. So bride's family is related to groom's family, and groom's family is related to bride's family by the wedding of this bride and groom. And that is the function f. So bride's family has a specific relationship with the groom's family members and vice versa. And mathematically, this is called as a transformation relation. So we have taken 3 different examples in our day-to-day life, and we'll try to understand the canonical transformation using these 3 examples. Now, we have to understand the cyclic coordinates. So what is the meaning of cyclic coordinates? If any particular coordinate is absent in a function, then it is known as a cyclic coordinate. And we have taken example, function f is a function of q1, q3, q4, and up to qi. And q2 is absent, and that is known as a cyclic. It is generally not possible that all coordinates are cyclic in a function. So if all coordinates are absent, that is not possible. Mostly some coordinates are present and some coordinates are absent. So let us go back to our classroom example where all students are absent. It is not possible. If the classroom is off, means the classes are off, means the college or school is not working, then all students are absent. But when the school or college is functioning, all students are absent is not possible. So mostly some students are present, some students are absent. Similarly, mostly some coordinates are present and some coordinates are absent. Then what happens? Some coordinates are absent in dynamical function. So we try to understand that situation. Now consider a situation where the Hamiltonian H is a constant of motion and all coordinates qi are cyclic, means that all coordinates are absent, and that rarely happens in reality. So we try to understand that what happens. So Hamilton's equation of motion becomes del H by del Qi is equal to minus P dot I. Here all coordinates are cyclic and absent, and hence Qi is not a part of Hamilton's function. Therefore, we can write del H by del Qi and is equal to minus P dot I is equal to 0, because H is not a function of Qi, and therefore it is 0. And therefore, P dot I is equal to 0. And that means that dpi by dt is equal to 0, and pi is equal to alpha I is a constant. So momenta is constant under this condition. So under this condition, the corresponding momenta for cyclic coordinates are constant. So this is a very important result. Under this condition, Hamilton's function becomes in the form of h function qpt to a function h function alpha I. So q is not present and corresponding momenta are constant. So therefore, it is a function of alpha I. Now we come to the transformation equations. So transformation equations are relating the old system to new system. So old system is Q, P, and T with small letters. And new system is capital Q, capital P, and T. The transformation going from one set of coordinate, that is small qi, to a new set capital Qi is given as, so Qi function Qi small q and t, and this is known as a transformation of configuration space because there is no momenta part in this transformation. Simultaneous transformation of the independent coordinate and momenta from small qi and small pi to new one, capital Pi capital Qi and capital Pi is shown as, so Qi function is Qi QPT. Similarly, capital Pi function of small qp and t. So these are known as a transformation in phase space because it takes place for q and p to new capital Q and capital P. So this is a transformation in phase space. So we are going to focus on this particular transformation. Now, new and old Hamiltonian. Now, defining the new Hamiltonian as capital K, function of capital Q, capital P, and capital T. And defining the old Hamiltonian as H, small q, small p, and t. What is the relationship between the two? So we have to establish a relationship between the two. So new Hamiltonian equations are written in capital Q dot I is equal to del K by del capital Pi. And similarly, P dot I is equal to minus del K by del capital Qi. The old Hamiltonian equations are small q dot I del H by del capital small Pi, and P dot I is equal to minus del H by del small Qi. So it requires to establish a relationship between K and H. So that we are going to do that. To establish the relationship between K and H, let us take well-known Lagrangian relation. So we take a help of a well-known Lagrangian equation. So it is d by dt in bracket summation I q dot I del L by del Qi minus L a bracket over is equal to minus del L by del T equal to 0. Now, if you are considering del L by del T equal to 0, then it is a constant one if you take a differentiation. So therefore, it is summation q dot I del L by del q dot I minus L is equal to constant because derivative is 0 for constant quantity. Now, taking a constant equal to H or Hamiltonian. So considering that del L by del Q dot I is equal to Pi. So now constant is equal to Hamiltonian. So therefore, H Hamiltonian is equal to summation I Pi Q dot I minus L. And from that, we can write L is equal to summation Pi Q dot I minus H. Now we are applying a Hamilton's principle. So Hamilton's principle, we know very well that the del I or delta I is equal to delta the integral from T1 to T2 L dt is equal to 0. So for observing the Hamilton's principle, the path which is the shortest one, that is represented as delta I, that's the integral delta from time T1 to T2 L dt is equal to 0. So now applying this Hamilton's variation principle, that is delta I is equal to delta T1 to T2. And now we are putting the value of Hamiltonian or Lagrangian from above equation. So it is Pi Q dot I minus H function Qi Pi T dt equal to 0. And let us call it as equation number 1. Similarly, we can write for a new Hamiltonian. So again, delta I is equal to delta T1 to T2. Now we have to write the capital letters. So Pi Q dot I minus K Qi capital Pi T dt equal to 0. That is equation number 2. So now we have two different equations. Equation number 1 for the old system, equation number 2 for the new system. But it does not mean that both equations are right. So minimum path or stationary integral is for new system need not be the same for the old system. Now, it is not possible that equation number 1 and equation number 2 are equal. That is, the variation of I are 0, but does not mean that both integrals are the same. So variation of particular path is minimum in one system is not equal to the minimum line integral for the another system. And to establish a relationship between the two integrals, we assume the following relationship. So this is a very important relationship where the lambda in bracket pi q dot I minus h is equal to capital Pi q dot I minus k plus df by dt. Now let us see that what is meant by lambda. So constant lambda is independent of canonical coordinates. So it is simple constant. And f is a function of phase space coordinates with continuous second order derivative. So this is a phase space coordinates, and it is a continuous in second order derivatives. So that is the property of f. And for lambda is equal to 1, we have a simple equation. It is pi q dot I minus h is equal to pi q dot I minus k plus df by dt. On the right hand side, new variables, left hand side, old variables. And that is represented by equation number 3. Now, importance of lambda. A transformation is known as an extended canonical transformation when lambda is not equal to 1. So if we go back to the equation, in this equation, if lambda is not equal to 1, that is known as an extended canonical transformation. When lambda is equal to 1, then a transformation is known as a canonical transformation. So we have two different transformations. One is an extended canonical transformation when lambda is not equal to 1. And a transformation is known to be canonical transformation when lambda is equal to 1. Now we come to generating function. What is generating function? So f is the generating function. It is useful for specifying the exact form of canonical transformation only when half of the variables are old and half are new one. So generating function is having a peculiarity that half part should be old one, half part should be new one. And that is why it is working as a bridge connecting the two sides. If both are new or both are old, then it cannot connect the both sides. So it cannot be used as a generating function. So f is working as a bridge between the old and new canonical variables, like a bridge connecting the two sides of a river. So there are four types of generating functions defined. One is f1. It is a f1 function of small q, capital Q and T. f2 is a function of small q, capital P and T. f3 is a small p, capital Q and T. f4 is a small p, capital P and T. And we'll notice that f1, f2, f3, and f4, all the functions are having one coordinate or one variable small, one variable capital. And that shows it is a mixture of the new and old system variables. We have to establish a relationship between the new and old canonical variables. So that we are going to see in the next slide. The transformation equations, the relation between the new and old system can be established by deriving transformation equations using four different types of generating functions. So considering transformation for f1. So considering f1, small q, capital Q and T. Now using equation 3 and writing f1 for f. So it is pi q dot I minus h is equal to capital Pi, capital Q dot I minus k df1 by dt, because we are writing f1 instead of f. And now focusing on that, left hand side is as it is, right hand side pi q dot I minus k. And now converting this full differentiation into partial differentiation. So it is del f1 by del t plus del f1 by del qi, del qi by del t plus del f1 by del capital Qi, del capital Qi by del t. And now converting this variable like del qi by del t is q dot I, del capital Qi by qt as q dot I or capital Q dot I. So we are putting this small q dot I and capital Q dot I for del qi by del t and del capital Qi by del t. And simplifying equation and equating it to 0. So now bringing all these variables to a left-hand side and right-hand side is equated to 0. So that is what we are going to do that. So we have done like that, that pi minus del f1 by del qi, q dot I, minus pi minus del f1 by del qi, q dot I, and the last bracket is k minus h df1 by dt equal to 0. Now we have rearranged in such a way that the first bracket is in a multiplication of q dot I, and the second bracket is in multiplication of capital Qi, and last bracket is a relation between the new and old Hamiltonian. Now here we are thinking that the coefficients, here the coefficients with brackets are independent and not 0. So right hand side is equal to 0. So left hand side should become 0. And we have assumed that the coefficients means q dot I, capital Q dot I, they are not 0. So that only the quantities in the bracket should become 0, so that right hand side and left hand side are equal to 0. So we have to assume that the quantities in the bracket are equal to 0. So these quantities in bracket are equal to 0. So assuming that first quantity pi minus del f1 by del qi is equal to 0, then capital Pi minus del f1 by del capital Qi is equal to 0, and last bracket k minus h minus df1 by dt is equal to 0. And now equating it to quantity means bringing on the right hand side, it is pi, it is equal to del f1 by del qi, and capital Pi is equal to minus del f1 by del capital Qi, and last one is k is equal to h plus df1 by dt, and these are known as equation number 5, and these equations are the transformation relation for f1 generating function. So this equation number 5 are 3 transformation equations for generating function f1, establishing a relationship between the new and old system. So you will see that it is establishing the relation, so between the old and new system. Now coming to generating function of type 2 means f2 type. So taking a transformation is something like f equal to f2 q capital P t minus qi pi. So taking a transformation of this relation. Now we are just using equation number 3, where we have a relation that pi qi pi q dot I minus h is equal to, now we are putting the value for, that is pi q dot I minus k plus putting the value of f. So it is d by dt f2 type, small q capital Pt minus qi pi, both are capital letters. And now we are trying to take a differentiation. So differentiation of d by dt of qi and pi, both are capital letters. So that is what we have done in the next step. So left hand side is as it is, pi q dot I capital letter minus k. Now we are taking a partial derivative del f2 by del t plus del f2 by del qi by del t plus del f2 by del capital Pi by del t, and now taking a differentiation of qi pi, both capital letters, so minus q dot I pi minus qi p dot I, and we'll notice that one qi pi q dot I will cancel out with the minus q dot I pi. So the remaining terms are, left hand side is as it is, pi q dot I minus k and it will be cancelled out. So only the remaining part will be qi p dot I, and equating it to 0. And this equating it to 0, it is pi q dot I, qi p dot I plus k minus h del f2 by del t, and minus del f2 by del qi q dot I minus del f2 by del pi p dot I equal to 0. Now we have equated to 0, and now again segregate in form of brackets. So the variable coefficients are p dot I, and the first bracket is qi minus del f2 by del pi. The second bracket is coefficient is small qi, and the variable the quantities in the bracket is pi del f2 by del qi, and the last bracket is having minus k minus h del f2 by del t equal to 0. And rearranging the things, we obtain equation number 7. Now, as we have considered in the f1 generating function, we consider here in equation 7 that the coefficients of quantities in brackets are not 0, and therefore the quantities in brackets are 0, and therefore we have a set of new transformation equations. So these are the quantities given in the bracket, and from that we have written that pi is equal to minus pi is equal to del f2 by del qi, capital qi is equal to del f2 by del pi, and the last one is k is equal to h plus del f2 by del t. So this is equation number 11. Sorry, equation number 8. Equation number 8, there are 3 transformation equations for generating function f2, establishing a relation between the new and old system. So these are 3 more equations. And one can notice that in equation number 8, there is no minus sign. All the quantities are having a plus sign. So pi is equal to del f2 by del qi, capital qi is equal to del f2 by del pi, and last equation is as usual. So there is no negative sign in any transformation equation. Now considering transformation for f3. For this transformation, the generating function is considered as follows. So it is f qi pi small letters plus f3 small p capital Q and t, and that is equation number 9. And we can use this in equation number 3. So it is minus qi p dot I minus h equal to pi q dot I minus k plus d by dt f3 small p capital Q and t. Again, we can do the same mathematical process, very simple process, and we can rearrange the bracket, and we can rearrange the bracket to 0. And again, we have a 3 different set of transformation equation. So these transformation equations are qi equal to minus del f3 by del pi, pi is equal to minus del f3 by del capital qi, and last one is k is equal to h plus del f3 by del t. So again, we notice over here that all the transformation equations, the last one is same as the earlier 2, but the first 2 are having a negative sign. So first transformation equation was having a 1 positive sign, 1 negative sign. Second equation, transformation equations were having all positive sign. This transformation equation is having 2 negative sign. And let us see what is going to be for the last one. So considering the generating function f4, the generating function is defined as follows. F is equal to qi pi small letters minus capital qi capital pi plus f4 small p capital P and t. And again, using in equation number 3, we can write the left-hand side is as it is, minus qi p dot I minus h. The right-hand side now modified, pi capital Q dot I minus k plus d by dt f4 small p capital P and t. Again, we can do the same mathematical process that we have done it for first two type generating functions. And again, we can get three different brackets with coefficients, and we assume that the three brackets are equal to 0 so that we can achieve three more transformation equations. And again, in this transformation equations, we have qi is equal to minus del f4 by del pi. Capital qi is equal to minus is equal to plus del f4 by del pi. And last equation is as it is. So we have seen over here that again we have a one transformation equation is negative sign, another is positive sign. So this is similar to the first transformation equation, which was having one negative sign, one positive sign. Now, one can notice following things from the transformation equations. So in F1, the term is having a first positive, negative, last one is positive sign. F2 term, in F2 type transformation, both the transformation terms are having plus sign, last term is positive sign. F3 terms are having both negative sign transformation equation. The last one is positive sign. And F4 in the terms, we have a one negative sign, one positive sign. Last one is positive sign. So we can summarize that there is a symmetry that F1 is having a one positive sign, one negative sign, F2 both positive sign, F3 both a negative sign, F4 first negative sign, then positive sign. So this is a summary for the transformation equation sign. We have positive sign or negative sign, the nature we have summarized over here. Now we come to another important part that is known as a Legendre transformation in canonical transformation. So in classical mechanics, changing variable is obtained from Legendre transformation. So transformation from q dot t to qpt is obtained through Legendre transformation. Now, what is Legendre transformation? This is a transformation which is commonly observed in mathematics. So considering a function of two variables, f, x, y, and the differential has the following form. So df is equal to u dx plus v dy. And u is represented as del f by del x, and v is represented as del f by del y. So this is a basic equation for the Legendre transformation. So to change the basis of description from x, y to new variables u and v, a function g is defined. And the function g is defined as g f minus ux. So that is represented as g f minus ux. And this shows the expression of Legendre transformation. So Legendre transformation expression is given by this equation, which is common in mathematics. So slightly modifying equation number 6, one can compare F2 Q capital P and T equal to F1 small q capital Q and T plus Pi capital letter Qi capital letter. So this is similar to the Legendre transformation, which is G equal to F minus Ux. Only thing is that difference is in the minus sign. Otherwise, both are similar to each other. So therefore, equation number 11 is considered as F Qi Pi small letters minus capital letters Qi Pi plus F4 small p capital P and T, equation number 11, that is considered as a double Legendre transformation. So equation number 11 is considered as a double Legendre transformation to obtain the F4 type transformation equations. Now we come to small the nature of identity transformation. So this is a very easy to prove that. Consider a generating function of F2 type. It is Qi capital Pi is F2 type generating function. So we know that F2 type generating function is having small q, capital P and T. And that transformation equation, we have to use F2 type generating function. The transformation equations are Pi equal to del F2 by del Qi. And now we put the value of F2. So it is del Qi Pi by del Qi. And we know that del Qi by del Qi is 1. So we have a Pi. So small pi is equal to capital Pi. Similarly, we are using another transformation equation. So Qi is equal to del F2 by del capital Pi. And we are putting the value of F2. It is del Qi capital Pi by del capital Pi. So del capital Pi becomes 1. So it is equal to Qi. So capital Qi is equal to small qi. Similarly, last transformation equation, capital K is equal to H plus del Qi Pi by del T. So there is no time in this time variable in this particular differentiation or partial derivative. So it is H plus 0 is equal to H. So small pi is equal to capital Pi, capital Qi is equal to small qi, and capital K is equal to capital H. So new and old variables are exactly equal to each other. So the new and old coordinates are the same, and therefore F2 Qi capital Pi is having a identity transformation. So it is known as the identity transformation. Now we have another transformation that is known as a similarity transformation. So considering the transformation F2, it's a function of alpha, small q and p. So it is a F2 type, and F2 type transformation equations we have to use. So it is Pi equal to del F2 by del Qi. Now we are putting the value of F2. So it is del alpha Qp by del Qi. And we know that del Qi by del Qi is 1. So it is equal to alpha p. And we can write small pi is equal to alpha Pi, capital P. And similarly for Qi is equal to del F2 by del capital Pi. Again, putting the value, it is del alpha Q capital P by del capital Pi. So del capital Pi by del capital Pi is equal to 1. So that is equal to alpha Q or alpha Qi. So we can write that Q is equal to capital Q divided by alpha. So there are relation that small p is related to capital P by first equation. That is by first equation. That is P is equal to alpha P. And the second transformation equation, small q is related to capital Q by second equation. So small q is equal to capital Q divided by alpha. So P is related to capital P, in which that P is equal to alpha capital P. And second equation, small q is related to capital Q, where Q small q is equal to capital Q divided by alpha. So in one case, it is in multiplication of alpha. Another case, it is a division of alpha. This is known as a similarity transformation. Now we come to the last one. That is, suppose the generating function is F1 type and is having a relation Qj, capital Qj, small qj. So using this transformation equation of first type, Pj is equal to del F1 by del Qj, putting the value of F1. So del Qj, small qj by del Qj. So del Qj by del Qj is 1. So it is equal to capital Qj. So Pj is equal to capital Qj. And similarly, Pj is equal to minus del F1 by del capital Qj, putting the value minus del Qj and by del capital Qj. So del capital Qj is 1. So it is equal to minus Qj. So in this transformation, we have a Pj, small variable, equal to capital Qj, and capital Pj is equal to minus small qj. And the last equation is same, because it is K is equal to H plus dF1 by dt, and we are putting the value of d capital Qj small qj by dt. There is no time variable, so that becomes 0. So it becomes h. So k is equal to h. So this is one more relation, transformation relation we have obtained. Now we come to the last part, that is the importance and applications of canonical transformations. So here I have summarized some very important applications of canonical transformation. This forms the basis of Hamilton-Jacobi theory. This is a very important theory in classical mechanics. It forms the basis of Poisson's bracket. That is again very important in classical mechanics. It is used in quantum field theory. It is used in neural canonical transformation. It is also used in Lie pseudo groups, mapping method in particle beam. Also, it is used in lattice dynamics of crystals. It is used in formulation of cosmology, and also used in determining the trajectory of space objects. So these are the few examples I have taken where the canonical transformations are used, but there are many more applications of canonical transformations in classical mechanics, in quantum mechanics, and in cosmology and various branches of physics. Now we come to the contribution of the great contributors. Sir William Rowan Hamilton, born in 1805, passed away in 1865. He was a great Irish mathematician and had knowledge of 13 different languages at age of 14, including many Indian languages. He was a born genius. Another one is Adrien Marie Legendre, born in 1752, passed away in 1833, French mathematician. So he gave a Legendre transformation theory, which is used in canonical transformation. And Joseph Louis Lagrange, born in 1736, passed away in 1813, Italian mathematician. He contributed for Lagrange and Lagrange equation of motions. And thank you very much for patient hearing. And thank you very much that this is a very important part of our classical mechanics studies. The students of undergraduate level and postgraduate level, sometimes they find difficulty in understanding the canonical transformation. Here I have made an attempt to make it a much more simpler one in considering that the canonical transformation by taking the examples from our day-to-day life. So I'm very much thankful to HRDC of Gujarat University and the coordinator and director of HRDC of Gujarat University for giving me this opportunity to have a discussion on classical mechanics topic of canonical transformation. Thank you very much. Thank you very much.